Alright class, in this video I'll be doing the second example from section 14.3. It says a tissue box is made from a piece of cardboard that measures 40 centimeters by 22 centimeters. Squares of equal side length will be cut out of each corner. The sides will then be folded up to form a rectangular box. What size square should be cut from each corner to obtain maximum volume? So, over here on the left, I have already drawn the two pictures that you're going to need. And the top is the picture of the box before, or the piece of cardboard before it became a box. And the picture on the bottom is the actual box. And the goal is to maximize that volume. So the objective, which I've just stated, is to maximize volume. And the volume of this box is length times width times height. So the volume is equal to length times width times height. And that is way too many variables. So what we're going to do is we're going to use all the constraints in this problem to make this volume function have one variable. So we're going to write down the word constraint here. Or in this case, there'll be constraints. So the piece of cardboard started as a 40 centimeter by 22 centimeter rectangle. So over here on the left, I'm going to write 40 centimeters. And down below on the red, we're going to write 22 centimeters. And then it says squares of equal size will be cut from each corner. We don't know the side length of the squares, so we're going to label those X. So this side length here that I'm highlighting in purple is going to be 40 minus 2x. And the side length that I want to label right here is going to be 22 minus 2x. So the constraints, we'll do the first one, the length, that will be 22 minus 2x. The width will be 40 minus 2x. And the height of the box will be x. So the volume, in terms of only the variable x, is length times width times height. And if we were to distribute and multiply those binomials out, the result would be 4x cubed minus 124x squared plus 880x. Again, the objective is to maximize the volume. So to do that, we need to find the location of the maximum by taking the derivative. So the derivative of the volume function is 12x squared minus 248x plus 880. And we're going to set that equal to 0. Now, if this wasn't a word problem, you would be required to use the quadratic formula to solve this. However, this is a word problem, so what you're going to do is you're going to use Desmus. You're going to use Desmus to graph v of x. The maximum volume is located when x is equal to 4.55. So the squares to be cut out should have a side length of 4.55 centimeters to maximize the volume.